NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. The largest telescope ever flown launched into deep space on Christmas Day 2021.
Today marks 1 year since the world first started seeing spectacular images of the cosmos that were captured by the powerful James Webb Telescope.
Minutes ago, a brightly lit galaxy older than the universe itself was discovered by the James Webb Telescope, heading toward Earth at an incredible speed. This surprising discovery has shaken the world of astronomy, raising alarms among high-ranking officials across the globe. Why are all the authorities running for their lives after receiving the groundbreaking discovery from the James Webb Telescope? Let us expose the imminent arrival of the ancient objects from space itself that could devastate Earth. The Webb Telescope's latest achievement. The latest finding is a galaxy named Jade's GSZ-14, now the furthest galaxy ever observed. This beats the previous record held by another galaxy, Jade's GSZ-13, which was also found by the James Webb Space Telescope. Jade's GSZ-14 was formed about 290 million years after the universe began. This timing is significant because it represents a period when the universe was just 2% of its current age, which is about 13.8 billion years. This finding is part of a larger project called the James Webb Space Telescope Advanced Deep Extragalactic Survey, which aims to explore the early stages of the universe. The fact that these massive galaxies existed at such an early time is puzzling to scientists because it goes against previous models that suggested the early universe was mostly dark and filled with gas, but not with such large galaxies. These findings from the Webb telescope suggest that our standard models might be incorrect or incomplete. The presence of such large galaxies early on suggests that the processes leading to galaxy formation might have started earlier or been different from what was previously thought. These discoveries have stirred a mix of excitement and concern among scientists. On one hand, there is enthusiasm about these breakthrough observations that challenge existing theories and broaden our understanding of the universe's early days. On the other hand, there is concern because these findings could mean that much of the current theory on the evolution of the universe might need to be revised or even rewritten. What does it mean for our understanding of the universe if massive galaxies were common in the so-called Dark Ages? This question is at the forefront of current astronomical research. Each new discovery by the Webb telescope not only adds more information, but also raises new questions about the early universe. This cycle of discovery and questioning keeps the field of astronomy vibrant and continuously evolving. As the telescope continues to function and peer further back in time, more information about our cosmic origins will likely come to light. These ongoing discoveries are crucial for scientists as they put together the pieces of how the universe came to be what it is today. The process of updating and refining our cosmic theories is complex and ongoing. It involves a lot of checking and rechecking of data, and it prompts a continuous reassessment of what we think we know about the cosmos. The discovery of galaxies like Jade's GSZ-14 so early in the universe's history is a clear sign that there is still much to learn about the cosmos. It is a reminder that the universe is full of surprises, and our exploration of it is far from over. The more we discover, the more questions we have, making the field of astronomy an ever-expanding frontier of knowledge. Scientists have recently identified a galaxy, Jade's GSZ-14, which has turned out to be much brighter than any other known galaxy, including the previous record holder, Jade's GSZ-13. Alongside this, another distant galaxy, Jade's GSZ-141, was discovered. Although it fits more closely with what scientists expected to find, it hasn't received as much attention. Currently, these three galaxies, including the new record holder, are the farthest ones confirmed through spectroscopic methods, showcasing just how unusual Jade's GSZ-14 is in comparison. The most noteworthy feature of Jade's GSZ-14 isn't just how far away it is, but its enormous size and brightness. This galaxy stretches over 1,600 light-years and its brightness doesn't stem from the typical processes, such as gas falling into a supermassive black hole. Instead, this light is produced by numerous young stars. According to researchers Stefano Carani and Kevin Hanline from the University of Arizona, the amount of light emitted suggests that this galaxy has a mass several 100 million times greater than that of the Sun. The creation of such a large, bright, and massive galaxy in less than 300 million years poses a significant question. How is it possible for the universe to form such a galaxy so quickly? This anomaly indicates that the processes involved in the formation of galaxies might be different or start earlier than scientists previously thought. The capabilities of the Webb telescope highlight that even if this galaxy had been 10 times less bright, the telescope still would have detected it. This suggests that the telescope might soon discover even older galaxies, possibly from as early as the first 200 million years of the universe's existence. This potential to find older galaxies raises expectations about what the Webb telescope might reveal next. If galaxies as large and bright as Jade's GSZ-14 existed so early in the universe's history, it challenges and possibly changes the understanding scientists have about when and how galaxies began to form. Each new discovery adds a piece to the puzzle of our universe's early days, but also complicates the existing theories. The discovery of Jade's GSZ-14, with its unexpected characteristics, hints at the idea that our current models of cosmology might need revising. The presence of such a massive and bright galaxy early in the universe's timeline suggests there are aspects of cosmic evolution that are not yet understood. As these findings accumulate, they provide a richer picture of the universe's history, but also suggest that many assumptions about galaxy formation might be incorrect. Continued observations and discoveries by the Webb telescope will be crucial in expanding our understanding of the cosmos. Each new piece of data not only challenges existing theories, but also pushes the boundaries of what scientists believe is possible in the universe. As more galaxies like Jade's GSZ-14 are potentially uncovered, the story of the universe's formation will undoubtedly become more complex, revealing not just more about the cosmos, but also about the limits of our current scientific knowledge. As we anticipate further revelations from the depths of space, the role of technology like the Webb telescope becomes increasingly significant. It not only serves as a window into the distant past of the universe, but also as a tool that might force a major rethink of the fundamental principles of astronomy. This ongoing path of discovery ensures that our understanding of the universe is always evolving, driven by the continuous questioning and testing of what we think we know. Every new discovery shows us how complicated the universe is, making scientists rethink their old ideas. How could galaxies develop so fast? The finding of a lot of oxygen in the galaxy known as Jade's GSZ-14 is stirring quite a bit of debate among scientists. This oxygen suggests that the galaxy is more developed than it theoretically should be for its age. Typically, oxygen in a galaxy indicates that several massive stars have already gone through their entire life cycles and exploded as supernova, releasing oxygen into the galaxy. The fact that we are observing such chemical maturity in a galaxy from just 290 million years after the Big Bang is causing a significant stir. This scenario raises a big question. How could such a complex process unfold so quickly? It challenges the speed at which we thought galaxies could form and mature. These early galaxies, showing such advanced stages of development, suggests a serious flaw in our models of how the universe evolved over time. According to current scientific understanding, galaxies this large and bright shouldn't exist so soon after the Big Bang. This observation might mean that either our estimates of the age of the universe are incorrect, or our fundamental theories about how galaxies form and evolve need major revisions. Currently, scientists are puzzled over how these galaxies could have formed so rapidly. The suggestion that these galaxies might have existed even before the Big Bang is something that has emerged from the desperation for explanations, as traditional theories fail to account for what is being observed. Previously, discoveries made by the Webb telescope have already challenged long-standing views about the universe. For instance, it was revealed that the universe does not expand at a uniform rate everywhere, and that matter is not evenly distributed throughout space. These revelations have already shaken the core principles of cosmology. Now, the presence of mature galaxies like Jade's GSZ14 so early in the universe's timeline adds another layer of complexity to the puzzle. Each discovery seems to further undermine the foundational theories of how the universe operates. These findings not only question the accuracy of our existing models, but also the methods and assumptions scientists have used for decades. The implications are profound, suggesting that much of what we understand about the formation and evolution of galaxies may be based on incomplete or incorrect interpretations of the universe's early days. As more data comes in from the Webb Telescope and other observations, the scientific community may need to brace itself for more surprises that could redefine our grasp of cosmic history. This ongoing challenge to establish cosmic theories is not just a minor adjustment to a few parameters, but could lead to a complete overhaul of our understanding of the universe. The debate continues as astronomers and cosmologists grapple with these anomalies, testing new theories and models that might better explain the complexities of galaxy formation in the early universe. The field of cosmology is filled with many complex theories that attempt to explain the structure and history of the universe. One notable theory, put forth by Nobel laureate Roger Penrose, suggests that our universe might have been preceded by another universe. This idea, called conformal cyclic cosmology, presents a scenario where the universe we live in is just the latest in a long sequence of universes. Instead of a single starting point, Penrose's theory suggests a cycle of universes, each beginning with its own Big Bang, leading to a continuous chain of cosmic events. This raises a continuous line of questions about the initial start of these universes, suggesting a never-ending backward trace through time with no clear origin. Additionally, the concept of multiple universes has been explored in recent scientific research. A December 2023 paper published in the Journal of Cosmology and Astroparticle Physics introduced a hypothesis that our universe's expansion might be due to it combining with other universes. This merging process is likened to the coming together of soap bubbles, where the integration leads to the growth in size. The authors argue that such a merging could be why the universe appears to be expanding faster than what the standard models predict. They propose that the young universe we reside in could have joined with a larger universe, causing a spike in the rate of expansion. Their calculations provide a better fit with the observational data of the universe compared to older models. Taking the discussion further, Jan Ambjorn, a physicist from Copenhagen University, has provided a fresh perspective based on his recent studies. He suggests that the known accelerated expansion of the universe, which has been attributed to the unknown dark energy, might be better explained by our universe merging with smaller emerging universes. This concept offers a potential explanation for some unusual patterns observed by the James Webb Space Telescope, such as the inconsistent expansion speeds in different parts of the universe and the surprisingly quick formation of large galaxies soon after the universe's birth. Despite these intriguing theories and the detailed observations made by the James Webb Space Telescope, the scientific community has yet to establish a definitive model that fully explains all aspects of the universe's behavior and its overall structure. Each new theory, while adding to our knowledge, also complicates our understanding, introducing more hypotheses that need to be tested and explored. As we continue to study the universe, we find ourselves facing an increasingly complex picture, filled with more unknowns and requiring even more elaborate explanations. The challenge remains to construct a clear and comprehensive picture that can encompass all observed phenomena and provide a clear understanding of the universe's vast and intricate nature. This ongoing pursuit in cosmology is a testament to the relentless human desire to grasp the fundamental workings of our surroundings, pushing the boundaries of our knowledge further into the depths of cosmic history. The story of the James Webb Space Telescope is about human creativity and teamwork, pushing the limits of what we can learn. The making of a super telescope. The James Webb Space Telescope is essentially a giant infrared observatory designed to view the universe with more detail than we have ever achieved before. This advanced piece of technology is a collaborative effort involving major space agencies, the National Aeronautics and Space Administration, the European Space Agency, and the Canadian Space Agency. The development was overseen by the Goddard Space Flight Center located in Greenbelt, Maryland, and the primary industrial partner for this project was Northrop Grumman. After its launch, the operations of the telescope were handed over to the Space Telescope Science Institute. This telescope is named in honor of James E. Webb, who was the administrator of NASA from 1961 to 1968. During his administration, he played a crucial role in promoting both manned space flights and extensive scientific research. His era was marked by the initiation of numerous missions into space, particularly probes sent towards Mars and Venus. These missions greatly expanded our knowledge of the solar system by providing new and valuable information about these planets. The concept of the James Webb Space Telescope originated in the early 1990s with the intent to surpass the capabilities of the Hubble Space Telescope. Specifically, it was designed to operate in the infrared part of the light spectrum. This capability is significant because it allows the telescope to see through cosmic dust clouds that block visible light, which Hubble cannot do. The main mirror of the James Webb Space Telescope is particularly large, at 21.3 feet in diameter, and is made up of 18 hexagonal segments that are coated with gold-plated beryllium. This large mirror is crucial as it captures more light, making it possible to observe objects in space that are much fainter and farther away than what Hubble could reach. One of the innovative aspects of the James Webb Space Telescope is its sunshield, which is as large as a tennis court. This sunshield is incredibly important because it protects the telescope from the heat of the sun, which could interfere with its observations. The shield consists of 5 layers of a special material that significantly reduces the amount of heat that reaches the telescope by over 1,000,000 times. This reduction in heat is critical because the instruments on the telescope need to be kept at very low temperatures to function properly. The telescope also includes a special cooler to keep its mid-infrared detectors at extremely cold temperatures. Despite the promising capabilities and the sophisticated technology of the James Webb Space Telescope, one might wonder about the practicality and value of such an expensive and complex project. The telescope not only showcases human ingenuity and our desire to push the boundaries of space exploration, but it also brings to light the substantial challenges and vast resources required to operate such an advanced tool in space. The scientific community watches eagerly, hoping that the telescope will provide groundbreaking insights into the universe, building on the legacy of James E. Webb and the profound anticipation surrounding this ambitious project. As the James Webb Space Telescope explores new frontiers, it carries the potential to unlock new knowledge about our universe, promising to enhance our understanding in ways we have not yet imagined. The James Webb Space Telescope was launched on Christmas Day, 2021, using an Ariane 5 rocket from French Guiana. It took a travel of 30 days to reach its targeted position in space, known as the second Lagrange point, which is approximately 932.000 miles away from Earth. This strategic position is essential as it allows the telescope to maintain a steady alignment with Earth while it orbits the Sun. This alignment is crucial for ensuring a stable environment for the telescope to conduct its observations without interruptions. Setting up the James Webb Space Telescope in space was intricate and involved several stages. Initially, the deployment of the telescope's sun shield was carried out, which is crucial for protecting its instruments from the sun's heat. Following this, the secondary mirror was put into place, and then the primary mirror, which consists of 18 segments, was assembled. The precise alignment of these mirrors was a critical and time-consuming task that took several months to complete. This alignment had to be perfect to ensure that the telescope's mirrors functioned as a unified optical system capable of capturing sharp and detailed images from deep space. Equipped with advanced instruments such as the near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the fine guidance sensor coupled with the near-infrared imager and slitless spectrograph, the telescope is designed to perform high-resolution imaging and spectroscopy. These instruments are vital for the telescope's primary mission to capture detailed images and gather spectral data of distant galaxies, star clusters, and other astronomical phenomena. They enable the telescope to observe objects in the universe with unprecedented detail, providing crucial data that helps scientists explore the cosmos. The goals of the James Webb Space Telescope are wide-ranging and ambitious. It seeks to explore the origins of stars and planets, understand the development of galaxies over billions of years, and investigate environments that could potentially support life elsewhere in the universe. A pivotal aspect of its mission is to study the earliest galaxies formed after the Big Bang, which are believed to hold keys to understanding the early developmental stages of the universe. In July 2022, the telescope transmitted its first series of full-color images back to Earth, which were groundbreaking in terms of the depth and clarity of the celestial objects depicted. These images showcase the telescope's ability to observe remote galaxies, regions of active star formation, and various cosmic phenomena with an extraordinary level of detail. This initial set of images confirmed the telescope's capabilities and provided a glimpse into the potential scientific discoveries that could come from its observations. The James Webb Space Telescope represents a major technological leap in our ability to study the universe. Its sophisticated design and cutting-edge technology have established new benchmarks for what can be achieved with space telescopes. By enhancing our capability to observe the universe in greater detail, the telescope is helping scientists to answer fundamental questions about the nature and origins of the cosmos. Despite numerous obstacles during its development, such as budget overruns and complex technical challenges, the dedication and expertise of the teams involved ensured its successful launch and operation. The collaboration among NASA, the European Space Agency, and the Canadian Space Agency exemplifies the importance of international partnerships in advancing the frontiers of space exploration. The telescope is now operational and continues to relay valuable data back to Earth, supporting astronomers worldwide in their quest for new discoveries. Its observations are expected to impact a broad spectrum of scientific fields, from studying planets outside our solar system to searching for the essential components of life. By providing a deeper and more comprehensive view of the universe and delving further back into the cosmic past, the James Webb Space Telescope is broadening our understanding of space and our role within it, promising to fuel curiosity and scientific inquiry for years to come. As the telescope finds more clues, the amazing patterns of stars and galaxies become clearer than ever before. The surprising discoveries of Webb Telescope. The James Webb Space Telescope has made several significant contributions to our understanding of outer space. One of its notable achievements is the successful capture of an image of a distant planet known as HIP 65,426b. This planet is much larger than Jupiter, measuring between 6 to 8 times its mass. It is located a substantial distance from its star, approximately 100 times the distance from the Earth to the Sun. Capturing images of planets that are far from their stars is usually challenging because the bright light from the stars can hide them. To address this, the telescope used a sophisticated tool that blocks out the light from the star, allowing the telescope to take a clear picture of the planet. Additionally, the James Webb Space Telescope has provided valuable information regarding the expansion of the universe. It has studied stars known as Cepheid variables to help scientists understand more about the Hubble constant. This constant is crucial because it helps scientists figure out how fast the universe is expanding. Although the telescope's data did not conclusively solve the ongoing debates about the exact rate of expansion, it has highlighted the differences between the various methods used to measure this rate, prompting the need for further research. Moreover, the telescope has observed the early stages of supermassive black holes in nascent galaxies. It captured light from these galaxies that were formed less than 1 billion years after the universe began. This light shows us how black holes can grow to enormous sizes over time. Understanding the growth and development of black holes is essential for learning how galaxies evolve over billions of years. In another groundbreaking discovery, the telescope detected complex organic molecules in a very old galaxy, over 12 billion years old. These molecules are similar to the ones that make up oil and coal on Earth. Scientists believe these molecules are attached to dust particles in space. Finding these molecules helps scientists explore the chemical processes that took place in the early universe, and possibly the formation of elements necessary for life. The telescope's capability to peer through cosmic dust has also revealed intricate details about regions in space where new stars are being formed. One of the most striking images from the telescope is of the Carina Nebula, also known as the Cosmic Cliffs. This nebula, located about 7,500 light-years from Earth, is a large cloud of gas and dust. It serves as a birthplace for new stars. The detailed observations from the James Webb Space Telescope give a clearer picture of the star formation processes, showing how stars come into existence and the conditions that favor their birth. These contributions by the James Webb Space Telescope are pivotal in expanding our knowledge about the universe. The data and images provided by the telescope not only improve our understanding of distant planets, the formation of stars, and the growth of black holes, but also push the boundaries of human knowledge about the cosmos. Each discovery adds a new layer of understanding and poses new questions for scientists to explore, ensuring that the field of astronomy continues to evolve and grow. The James Webb Space Telescope has gathered detailed high-definition images of supernova remnants, such as Cassiopeia A. This particular remnant is one of the best researched in the universe, and the James Webb Space Telescope's observations have unveiled new details within its inner structure. These details include clusters of gas and dust that are likely to evolve into new stars and planetary systems in the future. Furthermore, the James Webb Space Telescope has extensively examined the atmospheres of exoplanets, providing richer insights into their composition. For instance, when observing the gas giant planet WASP-39b, which is similar in mass to Saturn, but orbits its star more closely, the telescope detected a variety of gases in the atmosphere. These gases include water vapor, sulfur dioxide, carbon monoxide, sodium, and potassium. Such discoveries are vital as they offer a deeper understanding of the chemical dynamics at play in the atmospheres of distant planets, enhancing our knowledge of how these environments function. The James Webb Space Telescope has also made strides in exploring distant cosmic phenomena, such as the discovery of Sears 1019, a galaxy housing the most distant active supermassive black hole ever observed. Remarkably, this black hole is smaller in mass compared to others previously identified from the early universe. The detection of such a black hole offers fresh perspectives on how these enormous entities form and grow over time, contributing significantly to our understanding of cosmic development. Additionally, the telescope has studied a Wolf-Rayet star known as WR140, which is in the final stages of its life and exhibits a unique pattern of concentric rings. This pattern is created by the interaction between the star and a smaller companion star. Observations like these are crucial for scientists to understand the processes that occur in the later stages of life of massive stars, shedding light on the complex life cycles of such celestial bodies. In its examination of distant galaxies, the James Webb Space Telescope captured revealing images of the Phantom Galaxy. These images show heat-emitting structures of dust and gas that were previously invisible. The ability to see such details helps astronomers locate regions where stars are forming and provides the means to accurately measure the masses and ages of star clusters within these galaxies. The James Webb Space Telescope's contributions extend across numerous aspects of space study, significantly deepening our comprehension of the universe's history and the development of galaxies, stars, and planetary systems. Its advanced technology allows for capturing high-resolution images in spectra in the infrared spectrum, which unveils unprecedented details about the cosmos. These capabilities help scientists pursue answers to fundamental questions about our origins and the nature of the universe, pushing forward the boundaries of human knowledge and understanding of the vast cosmos around us. Through its innovative observations and data collection, the James Webb Space Telescope continues to be a pivotal tool in astronomy. Its findings not only refine our current theories, but also pose new questions, driving further research and discovery. Each piece of data enriches our grasp of space, offering clearer insights into the complex mechanisms governing the formation and evolution of celestial bodies across the universe. This ongoing exploration is crucial for piecing together the larger cosmic puzzle, helping us understand more about where we come from and how the universe we live in has come to be. Space is full of unknowns, making us curious and eager to learn more about the universe. Dark matter and dark energy, the big questions. In the immense reaches of space, many phenomena remain without clear explanations, captivating both scientists and those with a keen interest in astronomy. Among these, dark matter is particularly notable. Accounting for approximately 25% of the universe, dark matter is unique because it does not emit or absorb light, rendering it invisible to our telescopes. Scientists infer its existence from the gravitational pull it exerts on visible matter, like galaxy movements. Numerous studies have been conducted to unravel dark matter's true nature, yet it continues to elude a clear understanding. Some researchers propose it may be composed of yet unidentified subatomic particles, different from those constituting visible matter. Dark energy is another significant phenomenon, making up about 70% of the universe. It is thought to be the driving force behind the universe's accelerated expansion. The precise nature of dark energy is a major focus of ongoing scientific research. It might be a characteristic inherent to space itself, or possibly a dynamic unknown field. Comprehending dark energy is crucial as it greatly influences the universe's destiny, dictating whether it will expand forever or eventually collapse. Pulsars, which are rapidly spinning neutron stars that emit radiation beams, also capture considerable attention. Since their discovery in 1967, these cosmic lighthouses have been observed pulsing at consistent intervals. However, the processes behind their pulsing and occasional stoppages are not well understood. Research indicates that magnetic fields and currents may regulate their spin, but more detailed studies are necessary for a complete understanding. The Moon's magnetic field presents its own set of questions. Only certain parts of the Moon's crust are magnetic, possibly due to the remnants of an ancient asteroid impact, or smaller, more recent impacts might have caused localized magnetic fields. This selective magnetism is still being explored, with multiple theories under consideration, yet no definitive answers. Another intriguing topic is the unexpectedly low observed amounts of lithium in the universe compared to theoretical predictions. Some scientists believe that lithium may be hidden within star cores, escaping detection by telescopes. Another possibility involves hypothetical particles like axions absorbing protons and thus reducing lithium creation shortly after the Big Bang. The process of star formation within galaxies like the Milky Way also presents interesting questions. The rate at which these galaxies form new stars appears too high, considering their visible matter reserves. It has been observed that gas expelled from galaxies may return, contributing anew to star formation. This recycling of material could help explain how galaxies sustain their ability to form stars over extended periods. The ongoing quest to find extraterrestrial life remains a significant area of scientific inquiry and public interest. Despite extensive searches for signals from intelligent civilizations, no conclusive evidence has surfaced. However, the discovery of exoplanets that might harbor suitable conditions for life has rekindled hopes. Current and future space missions are dedicated to exploring whether life exists beyond Earth. The ultimate fate of the universe is a profound and complex question. Several outcomes are considered, ranging from an ongoing expansion leading to a desolate, cold universe to a potential collapse known as the Big Crunch. Key to these predictions is a deeper understanding of dark energy. Gamma-ray bursts represent another focal area of research. These bursts are the most powerful explosions observed in the universe, releasing vast amounts of energy quickly. Thought to result from the collapse of massive stars or from neutron-star mergers, their precise origins and mechanisms require further observational confirmation. The distribution of matter throughout the universe also raises complex questions. Observations suggest that a large portion of baryonic matter, which constitutes stars and planets, is unaccounted for. This missing matter is thought to reside in the warm-hot intergalactic medium, a hot, diffuse gas between galaxies. Detecting and studying this matter could provide vital insights into the development and structure of the cosmos. Is this ancient galaxy proof that our understanding of the universe is completely wrong? Tell us what you think, and don't forget to like and subscribe for more.